Welcome to Tech Talk 101, where we make technology simple. Today, we're diving into something that's literally powered by sunlight, solar cells. We see them everywhere, on rooftops, in calculators, even on satellites, but how do they actually work? We'll break down the physics behind solar cells, explore how much energy they can produce, and what factors influence solar efficiency. Plus, we'll take a look at the different types of solar cells and why switching to solar energy is more important now than ever. Ready to shine some light on this? Let's get started. Before we jump into the science, let's quickly answer a simple question. What are solar cells? Well, they're devices that convert sunlight directly into electricity. This process happens thanks to a technology called photovoltaics, a fancy term for light turning into electricity. Solar panels are made up of many solar cells working together. But the magic really happens inside each tiny cell. Let's take a closer look. Each solar cell is basically a sandwich made of two layers of a material called silicon. Silicon is a semiconductor, which means it can conduct electricity under certain conditions. Now, here's where things get interesting. One layer is called the N-type layer. It has extra electrons, which are negatively charged particles. The other layer is called the P-type layer, which has holes, essentially spaces where electrons should be. These two layers create something called a p-n interface. When sunlight, or more specifically, photons, hit the solar cell, they give enough energy to knock electrons loose in the silicon. These excited electrons want to flow to the N-type layer, while the holes flow to the P-type layer. And that movement is electricity. By connecting this flow to an external circuit, like a light bulb or your home's electrical grid, boom, you've got usable power. So, how much energy can a single solar cell generate? Unfortunately, solar cells aren't perfect. The average efficiency of a solar cell is around 15 to 20%. That means they only convert about 15 to 20% of the sunlight they receive into electricity. This might not sound like much, but when you combine hundreds or even thousands of cells in a solar panel, the energy really adds up. Several factors can affect how efficiently a solar cell works. First, there's the angle of the panel. Solar panels need to be positioned to get the most sunlight during the day. Second, the cleanliness of the panel matters. Dirt, dust, or even snow can block sunlight and lower efficiency. And finally, temperature plays a role too. It might sound strange, but solar cells don't like it too hot. Higher temperatures can lower their efficiency. Not all solar cells are created equal. The most common type is made from crystalline silicon. These are the ones you'll typically see on rooftops. But there are also thin-film solar cells, which are more flexible and lightweight. These can be used in things like backpacks or even building materials. And then we have the next generation of solar cells, like perovskite cells, which promise to be cheaper and more efficient in the future. But they're still in development. Now that we know how solar cells work, let's talk about why they matter. Solar energy is renewable, meaning we can't run out of it as long as the sun keeps shining. And unlike fossil fuels, it doesn't produce harmful emissions, making it a clean source of energy. Solar panels are also becoming more affordable, which means they're more accessible to people all over the world. So, to recap, solar cells convert sunlight into electricity using a process called photovoltaics. They may not be 100% efficient, but with advancements in technology, they're playing a big role in the shift toward cleaner, renewable energy.